Welcome back to the channel. In the previous video, we got the microservice example working on our local machine. In this video, we're going to get it working on AWS. But for this video, it's going to be a simplification. We're not going to do the production-ready networking setup, private IP, subnet segmentation. Instead, we're going to rely on a lot of the defaults that Amazon provides us. Why are we doing this? So we can get a simple working example. My personal experience, I've watched many tutorials, and what I find is that they try to go through a very complex example in the very beginning, and then it's very hard to see the forest through the trees. Or maybe that's backwards, I forget. Anyway, I'm going to give you a simple working example to get this working, and then we will expand and do the production-ready networking setup, etc. later on in this video series. So with that being said, let's start going. First thing we need to do is go to GitHub. I'll put the URL on the screen and also in the description, and just clone the repo. Copy the URL, open up your terminal, and just git clone. Paste, and then cd to that directory, and you have that. Next, we're going to actually look at some of the code. Before we get going though, real quick, help me out a lot. Subscribe to the channel, like this video, comment, sponsor me on GitHub sponsors right here, one time, or Patreon. Helps me out a lot, really appreciate it. Let's get going. Okay, so looking at the code, we have Visual Studio Code. If you followed along from the previous video, then you already know some of this code, but let's just walk through it real quick so we have a good idea. This is Flask app1 app.py. This is going to be microservice 1. This is going to be the entry point to our application, because what's going to happen is Flask app1 is going to make requests to Flask app2 and Flask app3 through these two routes. Flask app2 and 3 are not going to make requests to each other or to Flask app1. It's a simplification for this video series, but it's sufficient enough to demonstrate microservices on AWS. And we can see that right here, Flask app 2 and 3, where each one of these represents a different microservice. Also, we're going to have a single Docker file. This single Docker file is going to be used to run each one of the containers for Flask app 1, 2, and 3 on AWS. And how do we do that? We specify different environment variables, where the environment variables specify the entry point for the container, where for Flask app 1 container, it's going to be Flask app1 /app.py, container 2, Flask app2 /app.py, etc. That's how we're going to use one single Docker file. Okay, so let's go back to the code. This is Flask app1 app.py. Here's this AWS ECS deploy.yaml. You can find this in the .github workflows folder. If you scroll down to this env section right here, here are a bunch of predefined naming conventions. I'm going to use these throughout the video series, and I'm also going to use them in this video, obviously. Why am I doing this? Because later on in the video series, we're going to actually use this file, AWS ECS deploy.yaml, to automate deployments to AWS from GitHub Actions. You may not know what GitHub Actions are. You may not know what deployment means to AWS automatically. Don't be concerned. We're going to go through this later on in the video series. It's not going to come into play at all in this video. This is purely to keep name conventions consistent. I'm going to use them here, and use them in the next video and every video throughout here, just so it's easy to follow along later on in the video series. And the final file, it says docker-compose.yaml file, just in the top level directory. We're going to use this just to pull in the environment variables and the commands to run the containers. We're just going to specify it on AWS. If you watched the previous video, you're very familiar with this file. If you haven't, don't be concerned, not necessary. We're just going to do some copy and pasting. Okay, with that being said, let's go to AWS. Sign in AWS. First thing we're going to do is create the Elastic Container Registry. All right, so what is Elastic Container Registry, a repository? It's where we're going to store our Docker images. And like I said before, we're going to have a single Docker file, so we only need a single Docker image. Great. So let's create our repository. The name, we're going to pull this from the file that I mentioned previously, the .github workflows AWS ECS deploy.yaml. And we're going to pull it from right here, where we specified as AWS ECR repository name. Now, you don't have to follow these name conventions. You can do whatever you want, honestly. But it's going to make it much harder to follow along later in the video series. So that's why I highly recommend doing what I'm doing here. Okay, so we're going to paste it right here, as is. And nothing else to do, create. Great. So we can click into here. We have no images right now, so we're going to push one via the push commands. Now we're going to start running these. First thing, make sure you have AWS CLI installed. Also make sure you have Docker Desktop installed if you're on Windows or Linux. And make sure you also have Docker Desktop running right now. If it's not running, you won't be able to build the images. If you don't have the CLI installed, you won't be able to log in and push the images. Okay, so with that being said, let's go ahead, open up a terminal, and we're just going to paste the first command. Okay, login succeeded. We're going to build the image. Okay, image built. Scroll down. We're going to tag the image. And then finally, we're going to push the image. This might take a minute, so I'm going to fast forward after this is done. Okay, after that's done, we can go back to ECR, do a quick refresh, and then we see our image there. Great. So we have our Docker image loaded on AWS in ECR. Okay, next step, we can go to Elastic Container Service. First thing we're going to create are the task definitions. These are where we're going to specify our Docker containers. They're going to be initialized when we create our ECS services attached to the ECS clusters. The way this goes down is the clusters at the top, you create services within clusters, and then you attach task definitions to ECS services. So clusters, services, task definitions. We're starting at the bottom first. So let's create a new task definition. The name, we're going to pull it directly from the same file I specified in the beginning. We're going to specify everything here to be consistent throughout the video series. So we're copying from this ECS task definition 1. Going back to the code, just going to paste. Great. We're going to be doing Fargate here. We could do EC2, but we're doing Fargate because, honestly, I like Fargate better because it abstracts away a lot of the infrastructure requirements, the auto updates that needs to be managed. It just takes it all away from me, has AWS do it for me. I'm a developer, I'm not an infrastructure engineer, so I'm going to do Fargate every time. If you like to do EC2, by all means, but for this video series, we're doing Fargate. Keep going. Nothing to do here. We're going to allow the ECS task execution role, just the default. As I specified earlier in this video series, we're going to rely on a lot of defaults here. So we're just going to hand wave a little bit away. The name, so container details, container name, go back again. ECS task definition, container name 1. We're going to copy this. Paste. The image URI. We're going to copy this from ECR. So let's open up back ECR. Here's our repo, latest, copy the URI, and then paste it in. Great. Essential container, this just means if this container stops, then the whole task definition should fail. Why would you need this? Because you can actually specify more than one container if you wanted to. But for this video series, each task definition is only going to have one container. So we're just going to leave this as true for now, since we only have one. Port mappings, we're going to be running on port 5000 for Flask App 1, 5001 for Flask App 2, and 5002 for Flask App 3. Port name, we're going to be consistent with the same name we use for the container. Scrolling down. Environment variables. Now we have to add 3 here. The first, go into this docker compose.yaml file, is this Flask app equals Flask app 1 app.py. So we can do Flask app, go back, Flask app 1 app.py. Why do we have to do this? Because we're using a single Docker file specified in this ECR repository for all 3 task definitions. By specifying the entry point, we can run a single Docker file for each one of these Flask apps, each one of these microservices. It's a simplification for this video series, but it's one that takes away a little bit more of the legwork and lets us actually see a working product faster. Okay? We also need 2 more environment variables. This only pertains to Flask app 1, not Flask app 2 or 3. Because in Flask app 1, we also specify the port Flask app 2 and the port Flask app 3, which is just 5001. One more. Go back to the code. Again, we're in Flask app 1 app.py and port Flask app 3. And just 5002. Because again, Flask app 1 is the one making requests to Flask app 2 and Flask app 3. Flask app 2 and 3's app.py files do not make requests, and they don't specify either one of these environment variables. So we don't need to specify them in those ones. But for this task definition, we do need to specify them here. That's why we do that. Going down, All the logs, we'll leave it as is. And the only thing we need to add is the Docker configuration. We just need to add the command. We can copy it from Docker compose.yaml file right here. This is the command we want. Paste it right here. And the only thing we need to do is get rid of the quotes. Do that real fast. Shouldn't take more than a few seconds. And there we go. Great. Nothing else to do, so we can create. There's task definition 1. So we can go back to our task definitions and create 2 more. Task definition name. Go a little faster since we already did it for the first one. The next 2 are very similar. Just a little faster here. Task definition 2. Fargate again. Task role, same as before. Container name. Going back. Here's a container name. Copying it right here. URI, we already have it in the other tab. Paste it. Essential container, yes, just like before. Port mapping, container port, 5001. The name, keep it consistent. Environment variable, going back. Docker compose, scroll down. Flask app 2, Flask app. Value, Flask app 2, app.py, again because we're using one Docker file. Scroll down, no more environment variables, only for Flask app 1 do we need the other 2. Docker configuration, going back. Here's our command. Make this a little easier. It's going to do new, Control F, get rid of the quotes, go back, paste, there we go, and we can create. And last one, even a little quicker this time. Task definition name, right here. Here we go. Paste, scroll down, Fargate, task execution role, scroll down, name, right here, Flask app 3, URI, right here, paste it, such container, yes, port 5002, port name, just be consistent with what we have right here. Great. Scroll down, environment variable, just like the other ones. Docker compose, scroll down Flask app 3 right here, Flask app 3, app.py. As you can see, I try to make it as simple as possible with conventions. Scrolling down. Last thing, it's just Docker configuration. Man, it's gonna be exactly the same as this one, except it's gonna be 5002. So I'm just gonna copy that one as is and scroll down and create. Great. Let's go back. Now we have 3 task definitions. Perfect. Next, let's create the clusters. Now for this video series, we're going to have 2 different clusters, as I showed in the intro video with a diagram. Cluster 1 is going to have service 1 and service 2. Cluster 2 is going to have service 3. The reason being is that ECS allows you to communicate with microservices within the same cluster and across clusters. So I'm going to demonstrate both functionalities work correctly. So service 1 is going to be the entry point to our application with Flask app 1, like I said previously. It's going to make requests to Flask app 2, which is an ECS service 2 in cluster 1, and also Flask app 3 and ECS service 3 in cluster 2. So we need to create both of those clusters. So let's create a cluster. Cluster name, going back. We're done with this file, so we can close it. Going back to here, ECS deploy.yaml.github.workflows. And here's our cluster name 1. So copy this as is. Control V, scrolling down. Now namespace. We're going to use the same namespace for all of them. So we're going to get rid of this -1 and just put dash namespace. Because cluster 1 and cluster 2 are going to have this same namespace. Fargate, just like we did with our task definitions. Scrolling down, nothing else to do. Create. So this one is being created. Let's create our second one now. Create cluster. Go back. Same place. Now we're going to copy cluster name 2. Right here. Paste. And we're going to use the namespace. Again, Fargate and create. Okay, it's in creation. Now I'm going to wait until these are both done and fast forward a little bit. Okay, both clusters created. Now, real quick, we can see the namespace right now that we specified in this AWS Cloud Map. You can see right here, here's the namespace. What is the namespace? This is somewhat like the mesh network necessary for ECS to function correctly. So when you specify Service Connect, the AWS service that facilitates microservices on AWS, you have to specify the namespace that all the services will exist in. The namespace being shared is to allow the services to talk to each other. If they're all in the same namespace, they can all speak to each other. That's how we can talk to different services across clusters and within the same cluster. So closing this, going back. So now we have both of our clusters. Now we can create our ECS services. Remember the top-down? Clusters, services, task definitions. We've done the bottom with task definitions, and we've done the top with clusters. Now we're going to do the services. Now, before I do these, I want to make a quick note. From my experiences doing this and making this video series, if you create service 1 first, you might run into issues with the application being able to talk to service 2 and service 3. The reason being is that service 1 is only doing the client because it's only making requests to service 2 and 3, where service 2 and 3 are doing client and the DNS specification because they're being requested from. So it's recommended by both myself and from the support that I've spoken to create the service 2 and 3 first. So that's what we're going to do in this video series. Let's go into Service Connect Demo Cluster 1 first to create service 2. Scroll down. So we're going to click Create Service. All right, so Service Connect. We're going to create a service. It has to be Fargate because that's what we specified for the cluster. Task definition, we're creating service 2, so task definition 2, revision latest, service name, going back just like we were before, ECS deploy.yaml, here's service name 2, copy, paste right here, scrolling down, turn on Service Connect. What is Service Connect? This is the AWS service that enables microservices on AWS. This is what we have to enable. And we're going to do client and server. Namespace, the same namespace we specified when we created each cluster. Port mappings, port alias, Flask app 2. This is what we specified in the task definition for task definition 2. Discovery, not actually required, but the DNS we do need to specify. Where are we going to get this from? Go back to the code, Flask app 1, app.py. If you scroll down to the get message route, this is what you need to copy right here. This must match exactly. If it doesn't, then the DNS request will fail and you won't actually be able to return the endpoint. So we click paste right here, and the port is going to be 5001 for Flask app 2, as we specified previously. Scrolling down, there's not actually anything else to specify, but one thing I want to show you is the networking. The networking, we're hand waving things away here. We're not specifying the VPC. We're not creating a subnet. We're not creating internet gateway, NAT gateway, route tables, etc. We're hand waving it away to give us a working example. So we're relying on the default VPC, the default subnets for that VPC, the default security group, and we're leaving the public IP turned on. What's bad about having the public IP turned on? Well, if you have the public IP turned on, that means these ECS instances can be accessed from the public internet. Very bad. Malicious actors, malware, that whole shebang. Now we might be saying, okay, let's just turn it off. Easy peasy, right? Nah, can't really do that. Why? Because if you do this and you turn it off, that means that the ECS service can no longer pull the Docker image from the ECR repository. This isn't by design, it's just because we haven't set up the networking. We haven't set up the internet gateway, NAT gateway, etc. Once we do that in the next video, we will be able to turn this off and make it more production ready. Okay? So with that being said, scroll down, nothing else to do, and we'll click create. Okay, so service 2 is being created. Now let's go to our clusters and go to cluster 2. Because remember, service 1 and 2 are in cluster 1 and service 3 is in cluster 2. So we're going to scroll down and we're going to create service 3. Fargate, just like before, nothing really different, except we're going to have a different task definition, latest, service name, go to here. We're back in the ECS deploy.yaml, copy the ECS service name 3, paste it right here, scrolling down. Service Connect, again, what facilitates microservices, client and server, because Flask app 3 is being requested by Flask app 1. Same namespace, they all have to be the same. Port mappings, same thing we specified in the task definition. Discovery not needed. DNS yes. Go back to flatscap1 app.py. Copy this directly as is, must match. Paste, and then the port 5002. Great. Scrolling down. Same hand waving as before with networking. Default VPC, subnet, security group, public IP is turned on. Great. Create. And now it's going to be creating. And we see service 2 is also being created. So if we go back to our clusters, cluster 1, here's our service. We see it's running. So let's go ahead and create service 1 now. Okay, right up here, Fargate, task definition. Here's task definition 1, latest, service name. Let's go to our ECS deploy.yaml. Here's our service name 1 as specified right here. We're going to paste it, going down. Service connect, we must turn it on for microservices. Now, we don't need to do client and server. Why? We only need the client side only because Flask app 2 and 3 are not making requests to Flask app 1. Flask app 1 is the only one making requests to Flask app 2 and 3 to return values from their endpoints. Now, if Flask app 2 or 3 were making requests to Flask app 1, you would need client and server. But because this is the way we set it up in this video series for simplification, we only need client side only. But it has to be the same namespace. So like you see here, we don't have to specify any kind of port mappings like we did in service 2 or service 3. So a lot simpler. Networking, exactly the same as before, oversimplification, but it's just gonna work. So we're gonna click create. Click a refresh right here. And I'm gonna wait and fast forward after service 1 is finishing being deployed, and then we can actually access our microservices. Okay, service 1 is done being deployed. Now, one last thing we need to do before we can access our service is we need to go to our security group. So we click into our service, go to the top, configuration and networking, scroll down, and we just need to modify our security group to allow incoming traffic on port 5000, because that's the entry point for application is Flask app 1, which is running on port 5000. So here's our security group, click edit inbound rules, add rule, 5000, and we're just gonna do 0.0, which is anywhere. Again, this is not recommended. As indicated right here, AWS is telling you big yellow flag saying don't do this. But for this video, we're going to simplify things as we said. So save rules. Great. We can go back to our service. Go to our task right here. Click into our task. Scroll down. Click open address right here. And we're just going to do port 5000. And there we go. Hello world from Flask app 1. Now we can test our endpoints as well. So let's test both of them. Go back to Flask app 1 app.py. We're going to start with get message. Right here. Get message. Boom. We see it. So that's working fine. Now we also need to test get message across cluster. So we have inter-cluster connectivity. Great. Okay, so now we have a working example of microservices on AWS. This is not production ready. We don't have our networking set up. We're using public IPs for our containers instances when we should be using private IPs and a few other things. So stay tuned for the next video, and we're going to do everything in a production ready sense. I hope you learned a lot in this video though. If you have any questions, leave them below like always, and I'll answer if I can. If not, other people will help out as well. And yeah, stay tuned for the next one.